This course will be an overview of Linux bash scripting and ethical hacking for beginners. I will go over bash scripting and hacking. This course will consist of demonstrations of creating bash scripts and the different types of hacks. You should already have a basic familiarity with Linux commands and navigating the Linux terminal. You should also have some basic familiarity with ethical hacking. Linux shell scripting is helpful as it allows you to automate various tasks in Linux. I will teach you the basics to get started making your own scripts. We will write a simple script to get started. Use touch to create the file and call it myfirstscript.sh. Then we're going to make the script executable for all using command 775. We will then use vim to edit the script. So we'll type vim with the name of the script. At the top of the bash script, we'll add a shebang which tells Linux which interpreter to use, in this case bash. The shebang is written as follows: hashtag exclamation mark backslash user backslash bin backslash env space bash. To write a comment in the script, use the hashtag symbol. Comments are not displayed when the script is executed and are just there for you to write reminders or to make it easier for people reading your scripts. So here we'll write a comment. The echo command allows you to display text. Write echo hello world and then echo your name. We're going to save and exit out of the script using the escape key :WQ. And then we will run the script using /myfirstscript.sh in order to run it. We have officially created our first script. Now I will discuss variables, parameters, and prompting users for input. Let's start by creating a script that gets a user's name and their favorite sport. Let's call it favesport.sh and then use command 755 to make the script executable for all. As with last time, we will use vim to edit the script. We'll add the shebang on top that we used in the previous script. Here we will create the name and favorite sport variables and assign them to a parameter, though you can typically assign them to any value. In bash, variables are declared by naming them and assigning them to a value. Parameters can be anywhere from $0 to $9, and they allow you to enter data within the command line before executing the script. That being said, these variables will take user data to populate the variables. Now, we will write two echo statements that will utilize the above variables. Use $sign in front of the variable name in order to call it within the echo statement. Now let's save and exit. When running the script, I'll type my name and my favorite sport before executing. Now, as you can see, the script displayed the data I inputted. The first parameter took the first thing inputted, and the second parameter took the second. I'll also prompt the user for information once the script is already executed. I will demonstrate that in the sample script that prompts the user for age. So we're just going to create the script and make it executable for all and enter the script. Add the shebang. I will use read-p in order to trigger the prompt. So we're going to use read-p, and then the question, how old are you? Use the age variable. And then we're going to echo, your age is, and then call the age variable that will store the data inserted by the user. And then we're going to add an exit 0, which is utilized to prove that the script has been run successfully. Now let's just save and exit. And now, when we run the script, we will see that the age will be prompted, as it is right here, and is read back. Environment variables are a different kind of variable that yields information about your login session. These are predefined when the system is initially installed. Let's create a script that displays some information. We'll call it envir.sh, make it executable, and use Vim as our editor. We'll add the shebang. The $user and environment variable displays the current user of the session. So we're going to echo that out. Then the $hostname variable depicts the user's host computer. We'll also echo that out. And finally, the bash version environment variable will display the version of bash running on the user's computer. We'll add our exit 0, save and exit. When we run the script, we will see that all of the data we wrote in the script will display out, as it does here. And now you know how to use variable types in scripts to get data via parameters and prompting. Now I will introduce if, elif, and else statements to us creating a guess the number script. We'll create our script called guessing.sh and make it executable. These statements will allow us to provide different statements or actions depending on the criteria met. Start off by adding our shebang. So I will be creating a CPU variable and assigning it to the number to be guessed. In this case, we'll use the number 15. Now, we'll create a prompt for the user to guess a number, 1 through 50. We'll use the read-p command that we learned about earlier. We'll use guess as our variable. As far as our first if statement, we're going to use if $guess -eq standing for equals and compare it to the CPU variable, which equates to 15. So this statement will basically check if the user's guess equals the correct number to be guessed, which is 15. We'll add it then and echo you guessed it if the user has guessed the correct number. We'll add an elif standing for else if, which tests for the other condition, and we'll call it the guess variable, and we'll use -lt, meaning less than, CPU. So this will check if the user's guess is less than the correct answer. If that's the case, we'll echo too low. Finally, we'll add our else, meaning if the user guess is too high, and we'll echo the statement too high. Finally, we end it with a fee, which closes the if, elif, and else statements. Then we'll add our exit 0. When we run the script, we can test the game for a number of values and see that the game works. Start off by guessing a low number, guessing a number that's too high, and finally we're going to guess the correct answer, and it shows us all the responses. Now let's get into loops by writing some scripts. Let's start with for loops. For loops are loops that iterate through items within a list by running code for each item. I will create a for loop that iterates through pets inputted by the user until a certain one is called. So let's create the pets.sh script, make it executable for all, and edit it with our Vim editor. As always, let's add the shebang on top. Let's start by creating a pets variable and setting it equal to the app parameter. This will allow the user to input multiple values. As far as the for loop goes, let's do a for pet in $pets to iterate through each item within the inputted values. Do indicates what we wish the for loop to do, so we use an if statement to indicate which pet will be skipped over when iterating through the list. So we're going to call the pet variable and equate it to fish. So if the pet fish is called, it will be skipped over in the list. The continue statement indicates that this pet will be skipped over when listing the pets inputted. Then we're going to close the if statement with fee, and then we're going to echo a pet is a great pet to have. And this will include all of the pets inputted by the user. Then we finish with the done statement, echo the word done, and add an exit 0. Now when we run the script, we're going to declare a list of pets. And as you can see, it skipped over fish. Move on to while loops. While loops iterate while the condition is true. To create a script called counting.sh, make it executable. Use Vim as our editor, and we're going to add the shebang. Let's create a while loop that counts to the number 15. Set the count variable equal to 0. We'll start the while loop by telling it to loop while the count variable is less than 15. So we'll do this by putting while, open the brackets, and call the count variable the less than sign 15. We'll use do to indicate what we're doing within the loop, and we're going to echo num equals $count, which will read out to the user what number we're counting on. We're going to then add count plus plus in order to iterate through the loop and increment. We're going to finish this while loop with the word done. And then we're going to echo while loop finished. Add the exit 0. Going to save and exit out of the loop. Now we're going to run the script. And as you can see, it counts. Now I will go over functions and piping. Let's start with functions. Functions allow us to repeatedly call a piece of code. Let's create a simple function to see how it works. Add the shebang. I will start by typing function and naming it welcome, followed by brackets. Within the brackets, I will echo hello and a parameter, so it can be used interchangeably. Outside of the brackets, you can call the function by just typing its name. I can add values to change the parameter inputted. So we're going to save and exit out of that. We'll run the script, type my name, and as you can see, the parameter was picked up in the function. Now for piping. Piping essentially takes the output from one command and uses it as input for another. I will demonstrate this better by writing a piping script that will list the first 5 files in a directory and sort them. To create pipes.sh and add the shebang, I will declare a variable called files and set it equal to ls-1, which means to list in one column. Then we're going to add a pipe after that and write sort, which sorts the files. Then we're going to add one last pipe and add head, which lists the first 5 files, head-5. I will then make a count variable and equate it to 1. Let's use a for loop to iterate through the files. For file in files, then we're going to add the do, and we're going to echo the number of the file being displayed. Then we're going to add count ++ to increment through all the files. We finish this with a done and then add an exit 0. Going to run our script, and as you can see, this displays the first 5 files sorted in one column. A cross-site scripting attack is a malicious code injection that is typically performed with JavaScript and or HTML. Cross-site scripting is executed within the victim's browser. The malicious script can be saved on the web server, and then it is executed each time the user calls the functionality. Cross-site scripting attacks can be performed via other methods that do not require a saved script in the web server. The aim of the attack is to steal others' user identity, data, cookies, session tokens, and a lot of other information as well. Stolen cookies can allow the attacker to log in with other identities. 3 types of cross-site scripting include reflected, stored, and document object model, or DOM. Reflected cross-site scripting is an attack that occurs when a malicious script is not being saved on the web server, but is instead reflected in the website's results. Stored cross-site scripting is an attack that occurs when a malicious script is being saved on the web server permanently. DOM cross-site scripting occurs when the document object model, or DOM, environment is being changed, but the code remains the same. Here I will demonstrate a cross-site scripting attack within this capture the flag. So here we can insert the payload within the search engine, opening script tags, alert, open parentheses, and we're going to put apostrophe XSS, close apostrophe, close parentheses, and then we're going to do a closing script tag. And as you can see, this was executed within the browser. Now let's discuss SQL, or Structured Query Language, injection attacks. These are similar to cross-site scripting attacks because they involve inserting a payload and having it executed. When user input is not sanitized, these types of attacks are possible. SQL injection is an attack in which a SQL query is inputted into a web form as a means to extract information from the database. Inputting a certain query will allow you to bypass the website security features and directly get pertinent information from the database. As you can see here, select ID from users where username equals 1 or 1 equals 1 and password equals 1 or 1 equals 1. This is a line of SQL code. What we're doing with this query is telling the database that if you find an account where the username and password are 1, or if the statement 1 equals 1 is true, we will be granted access. Since the statement 1 equals 1 is always true, the database will grant you access. Here I will demonstrate a SQL injection attack on this simulated bank login. So we are going to insert the payloads discussed prior, 1 apostrophe or apostrophe 1 apostrophe equals apostrophe 1, and then we're going to do the same thing for the password. Press login, and we made it into an account. That concludes my course. I hope you're able to take something out of this, and best of luck on your journey with bash scripting and ethical hacking.